As we've hopefully seen in some of the experiments, if we bring a charged PVC rod near the middle of an aluminum rod, the ends of the aluminum rods will have the same effect on a charged object, a charged piece of tape or something, as the PVC rod would. Maybe not as much effect, but perhaps in some cases more effect, but the same type of effect. That is, if the PVC rod attracts an object, the ends of the aluminum rod will attract the object, and we conclude that the ends of the aluminum rod somehow obtain a charge that's of the same type as that on the PVC rod. To explain that, we simply note that the charges on the PVC rod are pretty much stationary. They're not free to move much. Whereas the charges on the aluminum rod are free to move wherever they want to, wherever they're attracted. Now, when the PVC rod comes in, negative charges are going to be attracted to the positive PVC rod. Of course, I'm assuming here that the PVC rod is positive. If the PVC rod was negative, then we'd get positive charges here and negatives out here. But for the picture as drawn, negative charges will migrate into the vicinity of the PVC rod. They'll be attracted to the positive charges, leaving behind unshielded positive charges. Okay? As we know, in a metal, it's electrons that move around, leaving behind unshielded protons. So there are a few unshielded protons here, a few extra electrons here attracted to the PVC rod. So the ends of the aluminum rod end up positively charged if we bring a positively charged PVC rod close. We also observe that if we bring a charged conductor, let's say on a thread, a charged sphere, bring it in, an uncharged conductor or an uncharged sphere. If we bring that uncharged sphere in toward the end here, it will be gradually attracted here, but as soon as it touches this end, it springs away. Now, what's responsible for that? Well, as the uncharged sphere comes closer and closer to the positive charges on the end of the rod, and I haven't sketched that here, but the negative charges on the conductor here will migrate toward this side, leaving positive charges on this side, and that'll give us a little bit of attraction between here and here, so that this rod will actually go over and touch the aluminum rod. But as soon as it does, these positive charges on the ends, which are effectively repelling each other like crazy, will migrate over, or some of the positive charges, in their effort to get away from one another, will migrate to the aluminum sphere, or to the charged sphere. And then the sphere will become positively charged, and when it does, it springs away because it's repelled by the positive charges here. Now, really, on a metal conductor and a metal rod, we don't have positive charges moving around. What happens is a little more subtle. The negative charges here combine with some of these positive charges, and negative charges run off of this sphere, leaving positive charge behind and neutralizing some of the positive charge in the aluminum rod. The effect is still the same, though. We end up with a little less positive charge on the end of the rod and a definite positive charge on the conductor, and the repulsion causes the conductor to spring away.